What have we learned as we've travelled around Australia? It's been an extremely interesting few months. The first thing I've personally learned is that climate change has become a whipping boy for everyone who is suspicious of government, suspicious of science, who doesn't like change, or is out of the loop for one reason or another. Right, we all have hundreds of pressures on us in our life, and businesses have hundreds of costs imposed on them. All of the anger about anything, whether you've just had a bad day or whatever it happens to have been, seems to have been focused on climate change for some people as a whipping boy. And I think, again, we've just got to start picking that apart a bit and saying, sure, this is change, nobody likes change, but change brings both threat and opportunity, and we need to understand that if we're to move forward. We've also found that respect for science has been eroded, not just for climate science, but for science as a whole. We have heard opinions voiced that suggest that, for example, climate scientists are part of a great international conspiracy to defraud the world of money in one way or another. These opinions are put out there by those with their own special interests and are extremely damaging. We've also seen in the media personal reputations destroyed, so character assassination of scientists and others played out. And I tell you, you never feel that as acutely as when you're standing up in front of the public and thinking, well, there's probably quite a few people out there who believe the stuff that's written about me or about any of our commissioners. And you realise that there are a few of us who are unbalanced. There are a few people out there who take this very seriously and for one reason or another decide to take or can potentially take action that is damaging. I think personally that has to stop. We have to get this debate on a much firmer basis than that, move away from character assassination and opinion and start dealing with the facts. And that, I'm very proud to say, is what the Climate Commission's all about. Another thing we've found is that there are gaps in people's knowledge, very large gaps in people's knowledge across all aspects of this debate. People are unclear about how climate change can be best addressed from an economic issue. They're unaware of the broad economic consensus around some approaches. We find that there is grave distrust of the science and misunderstanding, in fact, of what the science is saying. And we find that there is very little knowledge of what's happening internationally in terms of other countries moving forward to address this issue. But above all of that, we've found that there is a real hunger for opportunity, particularly in regional Australia. Wherever we go, with all of those downsides, we've found overwhelmingly that people are interested in the opportunities that this particular change represents, and those opportunities are very great in regional Australia, perhaps no more so than in a region like the Illawarra. And I hope through this conference that those opportunities get a fair airing. All of this is part of a process, and we have to remember that we're not the first people to deal with trying to get the polluter to pay. This is part of a long-going process. In fact, our civilisation simply would not exist if the polluter had not paid in the past. We'd still be living in cities awash with sewerage, where the air was unbreathable, where nothing had been done to deal with the basic amenities of life. So this is part of an ongoing process. The polluter pay principles is a foundation stone of our civilisation, and if we look at it in that longer term, I think we'll see that this is part of a very necessary process. It's very important that we work through it clearly, in an unbiased way, and understand exactly what is at stake. I think I've taken up more than my fair share of time on the podium. I'm going to now introduce our commissioners, and perhaps they can come up to the front here, because we'll doubtless take questions as we go on. The first one is Professor Will Steffen, who will be presenting a presentation on climate science. Professor Leslie Hughes, another climate scientist with particular expertise in adaptation and biodiversity, and Mr. Jerry Houston, who was until recently the president of BP Australasia and has, I think, 34 years, Jerry, in the oil and gas industry, and for his sins has taken on his role as part of the Climate Commission. So it's great to have you all with us. Thank you.
Okay, thanks, Tim, for the introduction. Now we'll start our tag team act of giving you a briefing on the science, the impacts, and what we might do to get on top of it. So I'll start off with a bit of science, and as Tim said, this is all from the audited, peer-reviewed science. The first graph I've shown here is the global air temperature record from about 1880 on up to the present, and this data comes from the best observing agencies around the world. The Australian data comes from the Bureau of Meteorology in Melbourne, and the rest of the data comes from their counterparts around the world. So it's the highest quality data. And you can see quite clearly, if I can get this, yeah, here we go, that in particularly since the middle of last century, although there's a lot of blips in there from year to year, from El Niños and La Niñas, the overall trend is quite clear. The temperature is rising. In fact, 2010 up here was equal warmest with 2005 and 1998. And this decade, the last one we've gone through, was significantly warmer than the 1990s, which was warmer than the 1980s and so on. So scientists actually use a plain English word to describe this. We use the word unequivocal. The fact that the Earth is warming and warming strongly is unequivocal. Nobody disagrees with that in the reputable scientific community. But this is something most people don't know about, and that is that most of the extra heat at the Earth's surface actually doesn't go into the air, it goes into the ocean, between 85 and 90%. And that's because the ocean covers 2/3 of the Earth's surface, huge heat capacity compared to the air. Here's the ocean temperature record, and again you see from about the middle of last century, from the 1960s or so on, the ocean temperature is rising quite steadily, and in fact here's the last decade from 2000 to 2005, it continues to rise. This really, in my opinion, is the smoking gun that the Earth's climate is changing, and changing very rapidly in a geological context. We can see some other evidence too, which is consistent. This is the sea ice over the Arctic Ocean, over the North Pole. It's ice that floats on the top of the sea. What we're looking at here is the rate at which this is being lost. And these data are taken during summertime in the Northern Hemisphere. This line here, the black line, is what the climate models say this ice should be doing. But the red line is what the ice is actually doing. So it's being lost at a fast rate, much faster than the models say it should be lost. Now I could go on, I'll stop there, but there's many, many pieces of evidence, all consistent, that tell you that the planet is warming. So I ask, why is this happening? You may hear, oh, well, the Earth always goes through cycles. It's natural variability. Well, we actually know a lot about those cycles. We know what drives them. We know the period at which they operate. This is not natural variability. And again, I could give you a lot of evidence for that. The principle, physical principle, is simple. There's a belt of gases around the Earth called greenhouse gases in the lower atmosphere. When you get on an airplane and fly to America or to Europe, you're actually flying above them. Most of those greenhouse gases are what we call the troposphere, which is 10,000 meters or below. So when you fly in an airplane and the pilot comes on and tells you what he's flying at, you're above those. But they have a particular physical property that's been known since the 1850s and 60s, and that is they trap some of the heat that goes out from the Earth's surface and retains it in the lower atmosphere and at the surface. And so that's what raises the temperature. It's a natural physical phenomenon that we've known since the 1850s. So if humans put more of these heat-trapping gases up, and CO2 is the most important of them in terms of its long lifetime, it's going to affect the Earth's temperature. So what we observe for us in science is a no-brainer. It's something that's really well understood. And to show you how we test that, here's a little test we do. We take our climate models and we don't run them forward, we run them in the past. So if you look at this time frame, it's going from 1900 to 2000. It's already happened, so we can test how good the models actually are. So the first thing we do is we say, all right, natural variability, we know about that. How should temperature have changed over the last century due to natural variability? And that's what it looks like. All right, solar activity came up around 1950. There was the odd volcano and so on, and that's what temperature should have done. Then what we do is say, all right, let's put the extra greenhouse gases in, because we know how much they were. We measured them. So we do that. That's what temperature should have done if we put in the extra greenhouse gases. Now here's a clear test for the models. And then what we do is the scientists go out, like our Bureau of Meteorology, and they measure what did actually happen to temperature. And when you do that, put the scientist in, there you go. So this, again, is a very good piece of evidence amongst many that tell us we know exactly what's going on here. And it's the extra greenhouse gases in the atmosphere that are causing this temperature rise. Well, what does this mean for things that matter for humans? And my colleague Leslie Hughes will be up here in a minute to tell you about your region. But in general, I just want to make one point. This is a little bell-shaped curve that many of you may have seen in your statistics classes. Take this as temperature. There's an average temperature for Wollongong, summer, winter, and so on. But there are cold days and there are warm days. And it's this extreme weather that often really affects us, a heat wave and so on.